Colleagues, it's another beautiful day for making asphalt. It's also a great day for talking about bag filtration checks. The purpose of this video today is to show and highlight the items of Pollution and Prevention and Control Act of 1999. Because there's two reasons why when we're operating asphalt plants we should control dust. Number one is our moral and ethical duty to not affect our neighbours and our communities with the adverse effects of what we do in terms of our operation. And secondly, we are duty bound by the Act of 1999 to control legally what we emit from our stack. So it's very important that we do daily, weekly, monthly, as well as 6 monthly and annual checks on our stack to make sure we're not emitting to the atmosphere more particulates than we are legally obliged to. One of the easiest daily checks to make sure that our stack is in good condition is to visually look at it. Coming up in a minute will be 4 shots of my stack taken about a minute apart. It's to try and show you the effect that the sun, different angles will make on the visual impression that your stack has. Have a look at them now and see if you notice any difference that the sun, the angle, the shadow makes. Do you think the stack looks clean? Is it billowy, silky steam emissions? Or does it look more sinister, such as filler or other particulates are involved in it? Let's talk in a bit more detail about your environmental permit in relation to stack test results. My stack test maximum permitted limit is 50 milligrams per cubic metre. Take a moment now to have a look at your environmental permit. Is it 50? Is it 75? Could even be 100. Next, have a look at your latest stack test result. You'll find it on the executive summary, which is usually page 5. It will tell you things like velocity of your stack, and how many milligrams of filler or particulates were emitted during the stack test. From this, you can work out how much filler or particulates were emitted from your stack in a working day. My maximum permitted is 50 milligrams, and if I were to emit it at my stated velocity, how much filler do you think would go up my stack? Small amount? Large amount? I'll show you. At 50 milligrams, it would be enough filler to fill this plastic box. Quite a lot, isn't it? So on a daily basis, it's that important that we need both managers and all site staff to observe your stack. It's the easiest, quickest and simplest way to ensure that you will be complying with your environmental permit and be courteous to your neighbours and your communities. Take a moment now to discuss between yourselves, what's your site limit? Do you know if it's 50 milligrams? Is it 100 milligrams? Just think about what the difference that emission rate will make. Because when we've had stack failures, it's not uncommon to have a 300 milligram failures. That would be 6 or 7 of these boxes that we've had full of filler every day going out your stack. That's how important it is to make sure you check your stack every day and on a monthly basis by checking the filtration method within your baghouse. The very best time to check your stack for emissions is while the main fan is still operating but no aggregate is coming through the plant. That way the emissions aren't masked by any steam coming out the stack. So if your main fan is on and no material is going through the plant and you're still getting a whiff of filler or an emission, you know then pretty much you've got a problem with one or several of your bags which is causing an illegal emission. We're now going to move on to practically checking the bag filtration system. So an hour ago, Cheddars and myself went up to the baghouse and we did a dynamic risk assessment. We completed our work safe. Out of those items, we've identified we could come into contact with moving material or moving machinery. There are slips, trips and falls, access and egress to the bag filtration unit, and also adverse weather We don't want to be going up there when it's windy. So the first thing we need to do is fully isolate the plant. So we're going to show you the Latoto procedure, lock out, tag out and try out on my particular plant. My podlock has my name in it, and on a red lock I'm the person in charge on this site. So I shall now isolate the plant. Key retained on my person. I've heard the main fans dropped out, and I know visually power has been lost to this, but we're not going to rely on that. We're now going to go upstairs. Now I've tagged it and included my board and prove that the isolation has been undertaken. So we're now going to try out to prove the isolation has been successful. I'm going to be mostly affected by the baghouse filter and the exhaust fan. Just checking on a couple of buttons. That's it, fine, nothing activated, proving the plant is now isolated. It's been an hour since myself and Cheddars came up to the baghouse to do a work safe. So I'm going to do a dynamic risk assessment now just to make sure nobody's come up, altered anything. Everything's looking good and the wind speed is great, so we're going to continue the task. I brought up my rucksack, which has got a radio. It's got my dust mask in case we need to pull any bags out. And I've also got my tools to take off the nuts and bolts on the guard. So we're ready to go with the inspection section. Let's start by looking at the outside of the seals. It's good that you have good rubber seals to make sure all the vacuum is contained. Just show you here, there's an imprint on where the seal has impacted on the lid, and it gives me confidence that the lids are firmly in. We look now at the wavy pattern of the filler. My baghouse emits 2 milligrams per cubic metre. You can still see there's a whiff of filler on here. That's nothing more than a little bit of moisture and condensation, and the filler is attracted to it. The reason why I've painted them black is it gives a really good image. If we'd had a bag failure, it would show a round ring of which bag had failed. So if yours are miscoloured, rusty, really good idea is give it a wire brushing and make sure that then you get it clean, and then apply some black hammerite, so when you are looking for it you see the round circles very clearly and you can identify which bag is the problem. We're now going to move on to check the integrity of the lid seals. The lid seals need to be proud in order to give a good seal on the lid to make sure the vacuum is complete. I'm looking at this point whether they're high and they're stable, but at this point I managed to find a low spot, a flat spot where it's been damaged. So consider when you're changing your bags, it's a really good idea to change the rubbers to make sure that all the vacuum is complete and you know the system is going to last for the lifetime of your bags. I'm inside the cell now and I'm looking for any evidence of filler within the plate. The side walls are nice and clean. I'm looking at the bags, there's no cages that are sticking out, and all the bags are firmly located into position. We're now going to check the bags themselves, and the way to do that is pull the cage up approximately 12 inches and let's have a look at the bags internally. Do the bags feel supple? Are they heavily condensed with filler? Do they feel like when you put the bags in for the first time? Good quality, plenty of life into them. As you can see from these, there's some discoloration. I'm looking at the cages now and there seems to be some condensing of them inside. They've been forced in. As a result of that, I'm going to consider on my 10-year plan when I need to consider the filter bag change as well as the filter cage change. Maybe convert them to stainless steel and change them at the next bag change to make sure that I've got integrity of them. Take some more bags out, don't just rely on one. Let's have a look at 3 or 4 within the cell to make sure that all of them are in the same condition and we've got good lifespan within our cages and our bags. So I've completed an inspection of the first 6 cells. You can check the weather, been up here 30 minutes and wind speed's still good. Don't forget, if you're any doubt, the wind starts to get up, any of these cells and these plates could get whipped off with the weather. So, stop the job, do a dynamic risk assessment. But in my case, it's all fine, so I'm going to finish off the other 6. We move on now to the cleaning mechanism. Most of our plants are of this design, which is a free clean mechanism. It consists of a brake, 4-spring brake, and a bearing underneath which needs to be well lubricated in order to turn the cleaning mechanism. We've got a rod arm with bearings at the end. This controls the stroke at which the free clean mechanism moves around into your bags. Very important that this is aligned, because if not, the free clean mechanism will attempt to go in between cells and not clean your bags fully. So this bar is crucial to the maintenance of the system to ensure that everything is cleaned. So give your rod a check. We've also got a proximity or a limit switch which makes sure that the cleaning mechanism is in the position it should. We've got a motor and gearbox. We're looking for oil leakage, we're looking for wear, anything else on the system that can affect its performance. So good luck round that to start off with. In this example, you can see the free clean mechanism, the cone, is trying to split between 2 compartments and therefore is not cleaning correctly or applying the maximum amount of force in order to clean the bags. This results in a lack of extraction and a possible failure of the system. As with all guards, to protect from moving equipment, we must ensure that the nuts are tool tight. Please look at your system to make sure you're not using ring nuts that could be hand tight. As with all inspections, please make sure you use the QR code to scan and record the inspection. This gives an opportunity to take videos and photos so you can refer to your inspection when you do it the next time. We've talked about the free clean method for baghouse cleaning, and this is the other system we have on some of our asphalt plants. It's a pulse jet cleaning system, or reverse jet cleaning system sometimes it's referred to. Quick explanation of how it works. This is the dirty side, so it's extracted air off our dryer, comes in and it hits a baffle plate. That stops the energy of the heavier particles, which falls down towards the bottom. This allows the light dust then still to be extracted through the filter bags, is extracted clean, the free air goes through, the clean air goes through the filter bags, up to the top and goes through the clean side. The way this operates that is different from the other system, it uses compressed air. On there we've got a pipe with some tubes that go down there, and it literally fires a pulse of compressed air that goes into the filter socks and cleans, mechanically shakes off the filter cake that goes around the filter bags, that allows it to drop down into our rotary valve to whatever then receiving hopper or system we have underneath. To explain in a bit more detail how the system works, we have this nice little diagram. We have the tube with the sprinklers that shoot down, and basically that's just one. A tube, compressed tube, goes into a seal, and there's your filter bag. A jet of compressed air is forced down into a single compartment, a row, and that blasts off and mechanically expands, which moves the dust off the side of the filter bags. So let's talk about now how this system can be affected. Compressed air is key to this system. What we need is a stable, dry supply of compressed air that allows it to come in, shoot through the bags and clean it. If you were to have moisture in it, all you're doing is injecting moisture into the filter medium, which will help to clog it up and reduce efficiency and your extraction. The other issue is the rotary or flat valve. If this is poorly maintained, it will either not let the filler go through properly, or worse, allow air to be blown through the system, so more filler is going through and gets to the bottom of your bag. That will blind up, degrade the bottom of your bags and create the same kind of problem with the other one. You get a hole and you just get filler going straight through to the clean side as an emission. So the two parts that are crucial to a maintenance system are the compressed air. Make sure that your air dryer is serviced by a competent person every 6 months. And probably more important is your rotary or your flat valve. Schedule in for your maintenance costs every 12 to 18 months to replace this rotary valve. Because when we do have a stack test, £660, and we have a failure, typically you would have to change the bags, change the valve, everything comes to a category A. It's a failure. We need to be ethically minded about what we do to prevent all stack test failures. And rotary valves are about £3,000. Schedule them in, put them on the 10-year plan. Chances are, in terms of root causes, if this is a major plot, you won't have a problem with stack tests. Let's now look at a pulse air jet system in practical application. Pulse jet system in operation. We have the air cylinder charged up to 100 psi, and we've got solenoid valves which just shoot air onto individual rows that help clean the bags. Now we've got the lid off, you can see the firing tubes with the nozzles underneath. Underneath them is a metal cap that protects the bags and allows a pulse of compressed air to go into the bags, which mechanically shapes them to allow the filler to be removed. You can also see in this example some historical filler, so the best practice of this will be to remove it. While we're inspecting this lid, now it's off, you see evidence of historic dust. Seals are in place around, but we just found this one. It's missing on this corner, so we just need to attach it. Again, good practice would be to sandblast all this off, grind it off, and then paint it black to be able to see any fugitive release of filler during production. So we've now checked all the cells within our filtration system, and if we've found one or two sections that are a problem, what do we do now? We have to change the bags, of course. But what happens if we've got no bags on site? It's a real problem trying to get them from another site, matching up bags, and the lead time may be a long time from the manufacturer. So recommendation to you all is keep at least 15 to 20% worth of your capacity in terms of bag in stock so you can change them at any time. If you do happen to have one that is burst or a section that is a problem, make sure you note it on a log, on a diagram, so you know exactly what bags were burst and you can go to them as a history. Put that on your QR code, you've got it forever in reference to check to make sure that that's not a rubbing area or an area of concern for in the future. Something else to consider about your extraction system, particularly in wet winter time, is the blocking up with wet aggregate of the feed end of your dryer. If it blocks that end up, which you'll see a photograph of shortly, it will affect the ability of the extraction system to take air off to go to the baghouse. This will adversely affect the performance of the cleaning of your baghouse mechanism. We've had 3 occasions so far this year where we've had to go inside the dryer and clean out the feed end because it's been completely blocked up with wet aggregate from our own quarries. Moisture is the enemy of asphalt plants. As we can see in this internal inspection of the dryer, just how much aggregate is built up onto the lifters. This will affect the efficiency of your lifters being able to lift material into a curtain of your burner to ensure dry material. And as we go towards the back end of the dryer, you'll see the massive build-up of aggregate. This will stop the dust extraction operating correctly and will adversely affect the operation of your dryer. With the back end of your dryer now blocked up, the dust extraction system will now concentrate on your inclined feed. That will now suck wet material into your skimmer baghouse, stopping your plant. In winter and periods of particularly wet weather, you really do need to keep an eye on your incoming aggregate sources, because if it's wet, you're just going to have the same problems that I've had with blocking dryers up. Get your loading shovel drivers to load a foot above the stockpiles to stop this. Now you've seen this video, please take 20 minutes in your next communications meeting to discuss and enlighten your staff on the issues that could affect your dryer and therefore your stack test, because none of us wants a category A stack test failure and emitting to the atmosphere. We've talked about the issues that can present and the fact that we all strive as CEMEX to comply with the law and to be good neighbours.